Okay, so if you look through the glass over here,
Where are we now?
this is the CNC lab. We're staying in the CNC.
CNC stands for
Computer Numeric Controller.
Computer Numeric Control. Very good.
And then over here, we have our basic design lab where you would do stuff like AutoCAD, Inventor, which is 3D modeling, and Revit, which is residential kind of building and architectural software. These are the two labs that I'm in charge of. My office is over there in that little closet. So then whenever you come back in here, you have different types of CNCs that they all do different things. This is the Bridgeport, and it actually has an automated tool changer. So the bits, the drill bits that we were seeing downstairs, this you can program it to know where it goes and change it for you, and then it will remember where it put it and go back and get it again for the next tool path. And so you would put a material in there, and you would design a 3D object of whatever you want on the computer, and then you put it in here up in the program and run it. And this actually has different axes. It can go X, Y, Z. So a lot of things, especially over here, we'll get to looking. It only has two axes, which is left, and then it's downward. This can do a little bit more. You can go up to even more axes. I've seen 8 axes where the table will move, or you can get different angles. It's just for preference, but it gets more expensive the more axes you have. Behind you, we have a CNC lathe, like the metal lathes we saw downstairs, but instead of doing it yourself, you design it and program it, write the G code, and it will turn it for you. If I can show it here. So you can see a little bit, there we go. Inside of it, you have your basic chuck, and then what's different about this as opposed to downstairs is like right here is where all the tooling happens. You may write it on the computer, but then the machine will do it all for you. To release it, you have pressure, air pressure, and a collet closer and a regulator, so you would open that up before you can release your material. And like I said, this is if you didn't hear me, this is a lathe, so it's turning, and it only has 2 axes, which is the turn and the cutting, so it doesn't need to go up and down and side to side. This is the solution bath for the 3D printer. The reason it's in here is because it's really messy and not great on electronics. So over here, this is a more manual CNC where you would work the axes yourself, and then it works with you, but you need to operate it instead of being fully autonomous like over there where you just code it and put it in. Here we have the ShopBot, which basically it's mostly for flat wood. So you would take a blank, maybe like a 2x4 sized thing, or a whole sheet, and it can cut the designs and patterns out. But you can also do things like crown molding for like ceilings around the center. You can do that with this, but it's a very basic thing. It doesn't have the capability of coming from the side. It's very up and down, side to side type of machine. Again, you program this. It doesn't use G code, and I'm not familiar enough with it to tell you how it does it without G code, but I know it doesn't use G code. You just again design your object on the computers, and then through a process of coding can code this. And I know a couple students come in here and use it, but other than the occasional like Greek paddle, if you know what those are. I haven't seen it do much of the intricate stuff, but there is an example of it over here, where you can see some of the different cuts it can make.
This was used in renovation of old Main, right? They used parts of this in doing new parts on old Main. So this is the same machine.
And I believe that is it for this lab. Everything's about the same, just like the 3D printer, it just does different procedures. This was a manual CNC that they were trying to make autonomous with a Raspberry Pi and computer, but they never got it completed.
Very good. Shall we give him a hand, please?